See Lindelof videos, implicit differentiation, finding second derivatives. So here we're given the equation x squared plus y squared is equal to 4, and we're asked to find the second derivative here. So not to be funny, but obviously if I'm going to find the second derivative, I have to start with the first one. So let's start by finding the first derivative. So let's declare that we intend to take this derivative. And the first derivative of x squared in terms of x is actually equal to 2x. The derivative here is 2y. That makes sense to everybody, but remember you have to also use the chain rule. Take the derivative of this inside piece, and the derivative of that inside piece is y prime is equal to 0. From here, I'm going to try to get, our stated intention was to find y prime, the first derivative. So what I'm going to do here is add negative 2x to both sides. So 2y times y prime is equal to negative 2x. Divide both sides by 2y. We get y prime is equal to negative x over y after I simplify a little bit, right? So I think that's a really good answer. Like, I'm cool with that, I think. So then what I'm going to do is this. Say, okay, this is the first derivative. We're asked to find the second derivative. What I always do is I just pretend that this is not the first derivative. Just say, okay, f, my function, is equal to negative x, y. Just say, I'm going to use the quotient rule here. And f of x is equal to x. F prime at x is equal to negative 1. G of x is equal to y. G prime at x, the first derivative of y, is y prime. So far, so good. Now I'm going to go ahead and start building. I'm going to start building my quotient rule. So we have y times negative 1, right? Minus negative x times y prime, right? Times y prime. All over y squared. This is just plain quotient rule, isn't it? I'm going to go ahead and do some of this. Keep in mind that this was our first derivative, right? This is our first derivative right up here, because I'm going to have to substitute that in just a second. So I'm going to clean this up and say I have negative y minus x times negative x over y. You with me on all this crap? And here we get y squared here. So we're actually getting there. We're looking for the first derivative of our first derivative. And this turns into negative y. Minus is positive. Positive times a negative is a negative. So minus x squared over y all over y squared. This looks like crap, but we're almost there. We have these two numbers here that we'd like to add together. So if I just multiply this one piece right here by y over y, I'll get y squared over y, won't we? And if you look at that, by extension, we get this. We get negative y squared minus x squared all over y squared. This is theorem of complex fractions, which is really easy. We just take this piece and we multiply by its reciprocal, which gives us this. We get y double prime, because we're almost there, I'm going to start calling it what it is equal to negative y squared minus x squared. Y squared times this y down here is y cubed, so y cubed. So we're almost there. Now it looks like kind of a pain, doesn't it? So we fill all that stuff in, and then all of a sudden we get this little trick thrown at us that shows up on the AP exam. So I'm going to do this. I'm going to factor out this negative 1. So there's my negative 1. I'm going to change these around so you can see this better. X squared plus y squared all over y cubed. If you're wondering why I did this, look, if you multiply this negative sign back in, we get all these pieces back, right? This negative sign creates, if I distribute, puts it back here and here, doesn't it? Because, and this is the stupid trick, if we look back at the top, it said that x squared plus y squared is equal to 4. That was our starting equation, wasn't it? So we have to substitute again. So we're going to sub that in, and we're going to get that the second derivative is equal to negative 4 over y squared. I'm sorry, that's not true, over y cubed. How did I lose that? How did I get up with that there? Sorry. Y cubed. So y cubed. All right? I know this is kind of a hassle. The more you do of this, the better you're going to get at it. If you have any questions or comments, please let me know. And if you haven't already subscribed, please do. I appreciate you guys.